Hey Brown Bombers, it's Miss Morel, and today we are going to talk about section 7.3. So we are finishing up the information we have to learn, but this is by far the largest section and kind of the meat and potatoes of this section or of this chapter. So make sure you get this. If you're not quite understanding, come and see me, and I definitely want to teach you how to do this because this is important. So we have some objectives here. We want to be able to write and name ionic compounds. We have some review vocabulary of non-metal. We have some new vocabulary. And then the main idea is in written names and formulas for ionic compounds, the cation appears first, followed by the anion. So remember, cation is positively charged, anion is negatively charged. So we don't have a lot of vocabulary, but there's a lot of learn to do. So when we write names, we write the cation first, the positively charged one, followed by the anion. And chemists around the world, they communicate in the same way using the same standard system so that we all can communicate together. A formula unit, this represents the simplest ratio of the ions involved. So that means it's kind of like reducing a fraction. Common monatomic ions, they're one atom ions, so like hydrogen, lithium, where you just see them stand alone. Oxidation number. So an oxidation number is essentially the charge of the monatomic ion. So when you look at your periodic table, up above each row, there it tells you what charge is most common for that group. So make sure you're looking there. And for the transition elements, our periodic table is kind of extra nice because it tells us in the top right corner of each box what the typical charge is for the transition metals. So make sure you're using that. Remember, oxidation number means it's charged. So we write +1, +2, +3, -1, -2, -3, things like that. The symbol for a cation is always written first, followed by the symbol by the anion. And then subscripts, that's a small number below, they represent the number of ions of each element in an ionic compound. So the total charge must equal 0. So when we have calcium chloride, the overall charge is always 0. Polyatomic ions are ions that are made up of more than one atom. So here we can see ammonium ion, which is NH4, phosphate ion, which is PO4-3, and polyatomics, they exist as a unit. Their charge of their subscripts, it never changes. And on the back of our periodic table, we have a list of common polyatomics and their charges. So we will be using that a lot the rest of this year. So flip your periodic table over and take a look at the polyatomics. So here we can see a list of some common polyatomics. And then an oxyanion is a polyatomic ion composed of an element, usually it's a nonmetal, bonded to one or more oxygen atoms. So for example, down here you can see nitrate, which is NO3, or nitrite, which is NO2, sulfate, sulfite. These all fall into that category because they have oxygens attached to them. Here we're going to take a look at how to draw this out. So we have magnesium. It has 2 valence electrons. We have iodine, which has 7. And so we are going to try and make all of these elements happy. So they need to have complete outer shells. So to make this simple, magnesium, it's going to give 1 valence electron to iodine, and this other one to this other iodine atom. And by doing that, magnesium is then happy. It doesn't have any extra electrons. We can't see them, but it now has a full shell below those its previous valence shell. And we can see how both of the iodines then would be complete and happy. So it's kind of handy how they just share. And so then all 3 of these atoms, they have completed the octet rule where they would have all of their valence electrons equaling 8. So when we write ionic formulas, we write the positive ion first and then the negative ion second. And then we compare their charges. So we write their charges up above and then we will crisscross them. Okay, and it can be a little hard with polyatomics. Polyatomics, you're going to draw parentheses around them if you need them. So let's take a look at this. Here we have lithium and we have oxygen. We would write their charges up above them like this, and then we're going to crisscross them, as we can see here. So we're going to give the 1 to the oxygen, and this 2 from the oxygen we're going to give to lithium. So we crisscross them and write them as subscripts, and then we always omit the number 1. So if there's a 1, we just can ditch it. Here we'll look at aluminum and oxygen. So we have aluminum here, and that has a 3+ charge according to our periodic table because it's in the 3+ column. We have oxygen, which is in the 2- column, so that's how we got those numbers. And we're going to crisscross them, and we'll write them as subscripts. So the oxygen, we take the 2 from that and put it next to the aluminum. And then the 3 from the aluminum, we put next to the oxygen. And even though we see the positive and negative symbols, we just omit those. So it's just telling us how many there are, so we don't write positives and negatives. Here we have lead and we have oxygen. Again, we're going to crisscross their charges. And this time we have a 2 and a 4. And this is where I like to think about fractions. And so we're going to write it in its simplest form. Both of these numbers can be divided by 2. So that means that we can simplify it. So then we're going to, where it was 2, it's going to be a 1. And we know we omit 1s. And so then we have a 2. Now let's look at a polyatomic. Here we have this polyatomic, and so here we have a 2, but our whole NO3 has a 1 negative charge. And so what that means is we're going to crisscross them, and so we would have a 1 here next to the calcium, so we don't need to write that, but then we would put a 2 next to the NO3. Now, we don't want it to say 32, so that's why we need to put the parentheses. And we also need to put the parentheses because we're saying that there are 2 nitrogens and essentially 6 oxygens is what this means because there's 2 NO3 molecules. All right, here's one more. We have zinc and we have this phosphate ion. We're going to crisscross their charges and we can see what we have here. So the 3 goes next to the zinc and the 2 goes outside of the parentheses next to the PO4, saying we have 2 of those PO4 atoms. All right, so when we write formulas for binary ionic compounds between the following elements, if we were to do zinc and iodine and zinc and sulfur, we would just write them like this. So zinc, we're going to crisscross the charges, and for sulfur, same thing. When we have them have the same charge, though, we are going to omit them. So hopefully that makes sense. I hope you guys have an awesome day. Watch the next video because the next video will be learning how to name them. All right, you guys, have a great day. Bye, Bombers.